So today we want to talk about two special logarithms. These come up a bunch. They probably remember these a little bit. But the first is called the common log, and that's just anytime you have a base of 10. It's just common because we have a base 10 number system, so it makes arithmetic really easy, which was originally what logs were for. So anytime you see written just the log of x, it's actually read as the common log of x, and it's the same as having a 10 sitting there. It's not wrong if you put the 10 there as the base, but it is pretty uncommon. You want to just really recognize that if you just see a log with no base, it's guaranteed to be base 10. It's just like the buttons on most of your calculators. And some of you have a place in the menu where you can change the base, but there should be just a log button on there. It'll be base 10. The second one we have is the natural log. Really a big deal in calculus, has some really neat properties about it. E shows up lots of places. We saw that in the continuously compounded interest and things. But with this case, it's written as ln of x. It's from Latin, Logarithmus naturalis or something, it's ln. But that would be read as the natural log of x. And it's the same as writing the log base e of x, but this you might occasionally see, this you almost never see. You almost always use natural log there. And there's going to be an ln button on your calculator. If you ever get confused and you have your calculator, the ln button on most of them, if you hit second ln, it'll be e to some power. Right? And if you look at common log and you hit the second button, it'll be 10 to some power. Like they try to pair inverse functions with each other on the calculator, just to be helpful. So on our worksheet on the front here, we just had some to rewrite in exponential form and simplify. Now, all of these, when they're base 10 and base e, you can simplify them by just typing them in a calculator. Now, obviously, on Friday's quiz, the ones that you can't do, I won't give to you. But a lot of them, if they don't seem to work nicely, you probably just need to type them in a calculator. So for this one, if we had the common log of 10 equals x, now what you might think about here is the base actually matches the argument, correct? So what are we expecting this to be? Just should be 1, right? It would be 1. So now if you did have to write it in the other form, it would be 10 to the x equals 10. So however you do it, you're going to get x is equal to 1. Or even better is just to say the common log of 10 equals 1. That's how we can work through that. We got some to jump around through here, but if I look at this one, the common log of 0.1, that can be a little confusing for people sometimes, but because a common log is just based on our decimal system, if you have a 1/10 or 1/100th or whatever, it's a lot easier to write the logarithm if you actually write it as 1/10. Right? If we write this as 1/10, well, that's the same as 10 to the negative 1 power, isn't it? So we could say the common log of 10 to the negative 1 power. Does the argument match the base, or does the base match the base of the exponential there? It does, right? This is an instance of our property that we used yesterday that said the log base b of b to the n is just equal to n. Right? So in this case, the common log, or the log base 10 of 10 to the negative 1 is just equal to negative 1. So we could say the log of 0.1 equals negative 1. Does that work there? So if it's a power of 10, we can really easily do this. Now there's some other examples on your paper that don't do that. Things like the log of 109. Now 109, not a power of 10, right? I mean, we know 10 squared is 100, 10 cubed is 1,000, so I guess we know the answer somewhere between 2 and 3. But if you wanted to simplify this, you would just need to type that one in your calculator. So you would just say, go to your calculator, you type the common log of 109, and that's going to give us about 2.037. Make sure that you're able to get that. And then it should ask you, I think it asks us to write it in the other form. So this would be 10 to the 0.037 equals 109 is how that would look when we put it in exponential form. But again, if it's a power of 10, you should be able to do it by hand. If it's not, you'd have to use a calculator. years ago, you'd use a log table, things like that. Okay, so here for our second part here, just some examples of using the natural log, right? So again, I mean, you could, like these two, we won't use our calculators. Expect you to do those two by hand. We just want to evaluate them, put them in exponential form. This one, 5's not a power of e, so you're going to have to use a calculator on that. It's part of the deal here. But here, as we look, we know the natural log has a base of e, correct? So the base of the natural, we don't write it, but the base matches the base of the argument. So they basically undo each other, correct? So what's our answer here? Just going to be 8, right? And if you switched it in the other form, you just get e to the 8th equals e to the 8th. Here, it's almost the same, but this is 1 over. So to get this e up to the numerator, we're going to have to say the natural log of e to the negative 2. Now, does our base of our logarithm match the base of the argument? Sure does. So our answer there is going to be negative 2. Now again, the natural log of 5, we don't know what that is. We have to use our calculator for that. So just, you'll use your natural log key of 5, and that's going to give us about 1.609 is how that would look there.